Smasho here, coming at you from the Smash News Network, least busted name in news, bringing you the most detailed space weather and solar imagery you'll find in the known universe. We've got interesting stuff going on. A new large sunspot group rising, trans-equatorial sunspots moving to the Earth-facing zone. Also a forecast for geomagnetic unrest and geomagnetic storm conditions by NOAA. We'll talk about it. This is the past 24 hours from SDO. A great composite series of wavelengths there. That's 171 plus 211 angstroms. Two different species of ionized iron. We've got some events happening both in the northwest and in the northeast. So let's take a brief moment to look at this new sunspot rising in close-up glory. These are some different wavelengths here. This is 131 plus 304 angstroms. I would note the plasma splashing back down onto the chromosphere right here. You can see that did produce a little bit of brightening there, some X-ray likely increase from that little splashdown flare. Here are some other wavelengths. This is 193 angstroms plus 304. Huge filament just to the northwest of that. And here are yet some more images. Here's 193 plus 171 angstroms. Thank goodness for the SDO. Now let's zoom out and take a look at sunspots in general here for a brief moment. That is yesterday plus today, and we've got at least 5 sunspots, make it 6 sunspots that are approximately the size of Earth or larger. 6 sunspots there that are larger than the Earth. So that's yesterday plus today SDO intensitygram. Here is SDO colorized magnetogram. This magnetic region down here, so far just a plage, does not appear to be a sunspot yet. We'll show you a high-res image of that before our meteorology segment. Let's take a brief look at volcanoes. And Stromboli featured a stronger than usual eruption there. There it is on thermal imagery. It was of greater intensity than an ordinary Strombolian activity, not to be confused with Calzonian activity. Sakurajima also erupting, flight level 070. Sakurajima producing a 7,000-foot ash plume. Same with Subanosejima, 7,000-foot ash plume over the Ryukyu Islands. Karengatang continues to erupt in an explosive fashion, producing a 9,000-foot plume of volcanic ash. Ibu now showing up back on the list here, the Indonesian volcano there exploding as well, 8,000-foot ash plume over Ibu. Semeru in Indonesia exploding, flight level 140. It's a 14,000-foot ash plume. 7,000-foot ash plume from Dakono as Dakono explodes. Kilauea still erupting effusively. However, the eruption there is constrained to the Halema-Uma'u lava lake. No overflows happening there. Popocatépetl exploding, flight level 190 over central Mexico from the 19,000-foot ash plume produced by Popocatépetl explosive activity. Fuego exploding, flight level 170. Sangay exploding, flight level 190. Revenador exploding, flight level 170. And we're not sure about Cotopaxi or Sabancaya. It's probably cloudy over Ecuador and Peru. Don't assume that they're not erupting. Next, looking at global seismicity. And there's the past 90 days. Largest quake of the past 24 was indeed a 6.1. Off the coast of Indonesia and Papua New Guinea. There's the location of that in the eastern portion of the Banda Sea. Due north of Australia there. That one came in at 9:37 Universal Time, just a few hours before we streamed the video. So let's go up the list here, citing everything over a 5 magnitude, like this 5.3 in the Mid-Atlantic Ridge. That was 15:55 Universal Time yesterday afternoon. Continuing on, Turkey. Continuing to see aftershocks there. There's a 5.2 at Turkey, following the horrendous 7.0 5 and 7.8 magnitude earthquakes that caused tens of thousands of deaths and caused tons of building contractors to get arrested. Why? Because of rampant corruption. Yeah, that's what happens in a banana republic, folks. Rampant corruption. It leads to people's buildings collapsing because of building contractors cutting corners. And, of course, inspectors taking bribes, most likely. That's how a banana republic operates. Rampant corporatism, fraud, and a lack of accountability. There was also a 5.2 in Japan. That one came in at 1:46 this morning, Universal Time. And then at 2:11, a 5.4 in the Mid-Atlantic Ridge there, right on the equator, in between South America and Africa. So going up to the top of the list here again, that 6.1 in Indonesia that occurred at 9:37 Universal Time. That was the largest quake of the past 24, and allow us to return to space. And thanks for stargazing with the Smash News Network, least busted name in news. Here's the last 24 hours and 171 angstroms. And the 10.7 centimeter radial flux has dropped to 163 solar flux units. There is the 1-year chart to put that in context. The black line is the radial flux. The red line is the sunspot number. Sunspot number still here over 100. Let's blast through some additional data here. Again, NOAA is forecasting a geomagnetic storm late tonight Universal Time into early tomorrow. So it should be subsiding when we put up tomorrow's daily space weather video. We'll see what happens. I'm expecting it to be much more minor than NOAA, but folks have been known to be incorrect, so we'll just have to see what happens. And yeah, a lot of differing opinions out there. Let us know what you think in the comments. We don't believe that will strike Earth, or if so, it'll barely be noticeable. Planetary K-index has calmed down a lot here. Global geomagnetism down to a KP 1.33. The planetary K-index, for you new viewers, is a measurement of global geomagnetism, and let's take a look at a visualization of Earth's magnetosphere. That's about 12 Earth diameters of magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework. If you want to read about the data sets that are used for that, click Details. There'll be a link to the Space Weather Modeling Framework. You can download all the software yourself if you'd like to create your own visualization. This is by University of Michigan. The past 4 hours depicted there. Here are the past 4 hours of Earth's magnetic moment from the ground. Our geospace ground magnetic perturbations there. Geospace delta B changes to Earth's B field. And things much calmer here than they were the past couple of days. The coronal hole high-speed stream's magnetic field has subsided quite a bit. We'll get into that here momentarily. So here's your real-time solar wind. You can see a slight subsiding, having reached a solid signal there of right around 500 kilometers per second, now dropping down to about 490 kilometers per second. Still an elevated solar wind speed there, solar wind density just under 7 protons per cubic centimeter. But the main story is this field change. So, yesterday we were reporting on a very strong BT, 18 nanotesla, and a very strong BZ of negative 13. You can see there about 24 hours ago. And that field got much weaker, and the negative BZ component shifted to the positive. So that's the vertical component of the magnetic field. Current conditions are a BT of 4 and a BZ of 0. So equal pull there as far as the vertical component of the magnetic field there. It's a lot less geomagnetically active than it was. So a couple likely CME impacts here also, very minor ones. You can see that little change in the plasma temperature there, as well as the density and solar wind speed. A couple brief little solar wind coronal mass ejection inputs there, very minor. not likely to have caused any sort of geomagnetic effects to be measured. Speaking of measurements, there are the GOES magnetometers, the GOES 16 and GOES 18. We should see this smoothing out here in the coming days. And let's take a look at what's going on with the heliospheric current sheet next. So we do have a South Pole current sheet speeding this way. An indication perhaps that that sunspot in the northeast will grow larger, or maybe it has other large sunspots trailing it. You can see an acceleration there of the South Pole current sheet. That is typically associated with sunspots in the northern hemisphere. Continuing on to our line of sight field plot, there's the sun's B field in blue, solar polar fields in green for north and red for south, and let's move to coronal holes. Possibly the most important feature of a solar cycle, at least in terms of what's going on with the actual heliophysics. So we've got a bunch of North Pole-oriented coronal holes here in the Earth-facing portion of the solar disk. Earth remains in the North Solar Pole, the North Magnetic Solar Pole, that is, as it's become equatorial as we ramp up towards solar maximum. So here are some great coronal hole images, and this one rotating in here is transequatorial. Those are the most geo-effective one. And again, for you new viewers, congratulations on realizing the channel exists, and thanks for tuning in. Coronal holes are the source of high-speed solar winds. So there are protons blasting out of that, and it's similar material to what you would see for a coronal mass ejection. So mainly hydrogen nuclei, but also some helium nuclei. It's about 90% hydrogen nuclei, and then a much smaller percentage of helium, electrons, and heavier elements will be blasting out of that coronal hole, and that should cause some effects on Earth. We can expect to see a high-speed stream from that in about 4 days on the 21st. So here's just 211 angstroms by itself. Let's rock back. There's 193 plus 211 angstroms. And there is 211 angstroms by itself. It shows a little bit more definition there. 211 angstroms, probably the best wavelength from SDO to show coronal holes. So let's move to sunspots next. Again, we've got this new large group having just risen in the northeast. It's at least beta gamma class. And before we get to sunspots, take a moment to press like, subscribe, share, and take a moment to visit our links. So there's a link below the video to the Smash Team. If you want to support the channel and increase the probability that these videos will continue to exist and remain publicly visible and free for all to view, please consider becoming a gold or silver Smash Team member. We are in the process of upgrading hardware and trying to continue to create these videos. So we're paid just this side of nothing to put them on YouTube. If you're viewing on BitChute, make sure you go subscribe on YouTube. We are a monetized channel. So, and thanks to our sponsors such as Hemp, Lucid, we'll get to that a little later in the video. And thanks for leaving comments, Mike Bordages, dear God indeed. And thanks again to the Smash Team members. SmashOmash.com/Smash Team is the official subscription services site of the Smash News Network, least busted name of news. You can find all kinds of links there, like links to the Hemp Lucid shop, to the Smash-O forum, the Smash-O merch, and lots more. So make sure you log in, click post. We send out email notifications for various things like video releases and natural disasters. Today's featured product is Mensa. It's our third bestseller, and it stands for Make Earth Not Suck Again, because the way to get out of a hole, folks, is to stop digging. You may have noticed some problems in the past 3 years. I would tend to agree. Have you noticed a bit of a lack of accountability? Have certain people been making decisions that are so terrible that they've been making Earth suck? Well, forgive, remember, and hold accountable. Never forget. That's so 2019. Forgive, remember, and hold accountable, and do your part. It's up to you to make Earth not suck again. And if you click the link below the video, you'll find our merch shop in order of best selling. So there are some of the items. Feel free to peruse the great high-res designs, which may or may not reflect the apolitical views of the Smash News Network, least busted name in news. So now we're on to sunspots, and we got this new group here, 3229. It's quite large. And the umbrae are, instead of being east and west of each other, they're northwest and southeast of each other. So, again, we'll show you some high-res imagery of that at the end of the video to check out the magnetic classification of that sunspot group. And let's take a look at some more 24-hour videos of the closest star. That's 1700 plus 171 angstroms. Let's swap out the 1700 for the SDO continuum. Let's zoom in a little bit closer. We'll let that one play through a second time. And then we'll drop the 171 angstroms. So let's take note here of if there's growth or evaporation of sunspots. Looks like they're largely stable here over the past 24 hours. No major changes. If I've missed something, let us know in the comments. Let's move on to energetic particles. There are your relativistic particle flux. No major changes in that. There was a long duration flare, which did produce a tiny spike. It was another large C-class flare, C9.1, almost an M-class flare, but not quite. And that was indeed the largest solar flare of the past 24 hours. Let's take a look at it from 94 angstroms wavelength. We may see a new sunspot rising down here, by the way. We will be keeping a close eye on that on the channel. So some significant sunspot groups there, some significant magnetic complexity. Here's 131 angstroms. So we've got mainly action in the northwest and in the northeast. Those are the places to watch. Here we've put up 171 plus 131 angstroms. And let's once again zoom in on sunspot 3229. So there's the northern hemisphere at large. And here's a close-up of sunspot 3229. I think we've got some more stunning 24-hour SDO movies. But first, let's take a look at what's going on overhead in Lehigh Valley, Pennsylvania. So it's very cloudy, but that's what's happening in the sky. Of course, you've got Mercury rising ahead of the Sun, and the Sun and Saturn very close together there near the ecliptic. That is our star chart from skyandtelescope.org. If you want to make your own, just put in your zip code and find out what's going on above your head. You can even advance it if you want to know what's going to be happening in an hour, 2 hours, 3 hours, 4 hours, etc. Let's do a solar system forecast. Here's a 7-day forecast. This is where heavenly bodies are currently located, and we'll advance this 1 week. We've got a crescent waning moon as we approach new moon. There's where things will be in 7 days. We're about 3 days from new moon. Shout out to all my reverse werewolves. Next, we'll look at coronagraphs to see additional coronal mass ejections. So you can see one coming out of the south, one coming out of the northwest. That's yesterday's imagery. There's the southerly coronal mass ejection. It's kind of low speed, and the northwestern one is kind of high speed. Here are today's images from George Mason University. Another 28 frames there. And let's take a look at the perspective of stereo A. There's stereo A on the left, and there is Soho Lasco C3 on the right. So we're just going to let those play through. That slow-moving CME to the south, that does not appear to be earthly directed. Keep in mind those frames are not synced. There's stereo A showing the southerly one, and there's stereo A showing the northwesterly one. Neither of those coronal mass ejections are directed toward Earth. One is way off to the south, and the other is off to the northwest. Here are some 24-hour movies featuring SDO 304 angstroms plus the Soho Lasco C2 and C3. Here we've zoomed in a little bit more. Also a little bit of CME activity there to the northeast, also not earthly directed. You'll actually be able to see the source of that one. It did come from the region of sunspot 3229, is it? 3229. That's that new group rising in the northeast. And let's take a look at filaments, since the likelihood of additional coronal mass ejections in the earthly region is nearly 100%, because we've got an inordinate number of filaments. So here's the view from Cerro Tololo, Chile's ground-based solar observatory, viewing hydrogen alpha and all these dark absorption features. Those are all filaments. This one up here becoming unstable. Patrick Stewart looking like it's becoming unstable. The Hulk Hogan filament here dropping out of sight. So if you'd like to name filaments after living people, we've got only one named filament, the Patrick Stewart down here, and it looks like it may be ejecting. So anyway, if you'd like to name filaments after living humans, make sure you join us on Twitter. Also on the Twitter feed, you can find pinned to our profile the link to the free samples. If you want to try out the Hemp Lucid mushroom gummies, whether it's for immune response, sleep, stress, or focus, check them out. Again, you'll find that link on the Twitter feed, pinned to our profile. Thanks to everybody who's picked up items from our latest and perhaps greatest affiliate/sponsor, Hemp Lucid. Again, you'll find that on the Twitter feed. And of course, all of our viewers are invited to name that filament. Make sure you name it after a living person. Filaments are a super important portion of space weather, as they could theoretically cause some of Earth's power grids to shut down. So, again, remember, folks, we don't need to see coronal mass ejections or even sunspots or solar flares to see. We don't need to see sunspots or solar flares for coronal mass ejections to occur. They happen all the time without those phenomena. And don't get them confused. They're separate phenomena. So, a bunch of filaments up there. I mean, this one up here is itching for a name. We've got some down here also. I mean, there are billions and billions of people to pick from. So name that filament over on Twitter. Make sure you follow us there for various other reasons. Also, we will be doing additional Twitter Spaces, which are like audio podcasts on Twitter. So that's another reason to follow us over there. That'll be exclusive content, and there's no telling what we might talk about on Twitter Spaces. So speaking of space, we're back once again, and not sure why Elon doesn't watch the channel. Hey, Elon, why don't you watch the channel? You know, like one of our viewers said in yesterday's live stream, if Starlink would have watched our content, remember when they lost like 47 of 49 satellites? Remember that? Because they launched directly into a geomagnetic storm. We forecasted that geomagnetic storm. Starlink launched anyway and lost over 90% of their satellites. So Tamitha Skov forecasted it, we forecasted it, and Tamitha Skov says that they could have just changed the perigee of the satellite launches and it would have completely avoided the geomagnetic storm. So, hey, Elon, how come you're not watching the Smash News Network, Least Busted Name and News? And how come our account is shadow banned, aka deboosted, on Twitter? Pretty pathetic and pretty idiotic when you really think about it. How many millions of dollars did that cost? You could have sent us that cash instead of wasting it and destroyed your own satellites. Here's the past 24 hours from SDO 304 angstroms. We'll also show the last about 2.5 hours from GOES 16 SUVI. We streamed it for like 14 hours yesterday on YouTube. More about that in a moment. But first, our bonus feature segment. So again, we've got some instability happening up here around sunspot 3229. Always interesting indeed. So don't be surprised to see this filament go flying as magnetism overpowers gravity in some situations, causing solar plasma to be headed right towards your doorstep. So here's our bonus feature segment, starting out with satellite charging hazards. It's clear sailing for satellites, and interestingly, we've seen some major changes in the total electron content, which we'll get to here in a moment. First, the GOES electron flux, and it's coming up off the ground there as we watch this coronal hole high-speed stream subside, and we await the possibility of a CME impact. There is our relativistic electron forecast model. No arguments there. That looks accurate to me. I would tend to agree with that forecast. And here's the one-year chart to put it in context. Again, we typically see very low levels of electron flux during coronal hole high-speed streams. Next, we'll take a look at the layer of the ionosphere where the GOES 16 and 18 measure the electron flux, the F flare, which is at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're unfamiliar with the penetration of electromagnetic radiation, thermospheric temperatures, and molecular densities. So we'll show the vibrational frequency and the anomalygram. There is your ionogram, courtesy of Australian Government Bureau of Meteorology. We'll make sure that plays all the way through. We feature it daily on the channel. Pretty sure we're the only channel that covers it. Here is your anomalygram, and we're seeing some wild swings here from low to high frequency anomaly. Of course, indications that the South Atlantic anomaly remains back where it was a couple of months ago over the South American continent. Great indication that that's where it is. Also, the South African anomaly has appeared to have moved north, so that is a change. South Atlantic anomaly here appears to be around the equatorial west coast of Africa. So anyway, that's your ionosphere anomalygram. That's anomaly in megahertz from a 30-day median. Let's show the latest image briefly. Pardon our lateness today, by the way, coming at you a little later than normal. It is a rainy, dreary day in Lehigh Valley, Pennsylvania. There's 1315 Universal Time ionogram and 1315 Universal Time anomalygram. We'll also show the total electron content, which has snapped back to normal here. So GPS errors are going to be looking a little bit more normal than they usually do, because I'm going to make it mo better. Anyway, this is the total electron content from your GPS satellite down to your handset. And we're seeing much more organized total electron contents here. Things looking like they're getting back to normal. So a lot less GPS errors can be expected over North America now, as we're seeing the total electron content much more constrained around the equator at noontime than it's been for the past couple of months. It was quite anomalous there for quite a while. That's your total electron content forecast showing the most likely places for GPS errors. So here's your latest intensitygram and your latest SDO magnetogram. Let's take a look at sunspot 3229. There are the umbrae, and there are the fields. It is beta gamma class. I wouldn't say it's beta gamma delta class, but there is quite a bit of activity going on up there, so don't be surprised to see even an X class flare come out of that region. Here's your full disk rock back. Let's briefly look down here and see if that is a sunspot. That is still just a plage. So that's where we go from our space weather to our meteorology segment. So let's do it. Starting out our meteorology segment. Yeah. With sea surface temperature anomaly and currents. Now keep in mind this data is a couple of days old. So that is actually from the 15th. And when we show the wind data and other things, they're typically on time. So always pay attention to the time and date stamps. If you weren't aware of this, again, this is slightly old data there. And what we're showing here is the Gulf Stream. And what's interesting about this is that there's some anomalously cold water mixed in with it. And there's some anomalously warm water here around Greenland also. So that's interesting. But the good news is that the Gulf Stream is still making it to Europe. So if you're waiting for the Northern Hemisphere to freeze because of the AMOC shutting down, the Atlantic meridional overturning circulation. It's just not happening. Ireland and Iceland are remaining warmed up by the Gulf Stream. And it's actually a little bit anomalously warm overall in that area. So not a ton of cold water floating around there. That's what's going on. Let's show the rest of the world's sea surface temperature anomaly since we opened that can of worms. There's the Atlantic Ocean and the Arctic. There's the Southern Ocean. It's anomalously cold where it meets the Pacific and anomalously warm where it meets the Atlantic and Indian Oceans. There's the Pacific, by far the world's largest body of water and largest surface heat sink. By the way, that's something important that people don't seem to understand. A lot of people seem to think that the atmosphere is an accurate measurement of Earth's heat latency, which couldn't be farther from the truth. Water has a very high heat latency, and air has a very low heat latency. That's why your swimming pool stays warm when it suddenly gets cold out. It takes a lot of energy to heat up water, and it costs a lot of energy to cool water down, obviously. So, anyway, the Earth's atmosphere contains less than 1% of Earth's surface heat latency. Things like the Pacific Ocean contain the other 99% of Earth's heat latency. And so the point is, the temperature of the water in the oceans is vastly more important for measuring the climate than the air in the atmosphere that's affecting your thermometer. You live in the air world. Most of planet Earth's surface is covered by water, which has a very, very high heat latency, even higher than most rocks. So anyway, water, it's the real source of Earth's heat latency. If you're not familiar with heat latency, well, you can take physics from MIT for free online. It's heat latency is the amount of energy, the amount of energy that's thermally held in a substance is heat latency. The tendency for it to retain heat. So a thing like aluminum has a very low heat latency. Ceramics have a very low heat latency. That's why they're used for heat sinks. Water has a very high heat latency. That's why it's used for things like your hot water heater. All right, so let's move on to meteorology here. That's what's going on for surface winds for the eastern world. This is what's going on for the jet stream for the eastern world. And we've got an S-shaped thing here, which everybody knows when we see things like letters or shapes. It, of course, must stand for Satan. You know, when you see the S forming there, a transequatorial S, that, of course, stands for Satan, which is, probably people using chemtrails and HAARP to control the jet stream. Just kidding, folks. That's utter fiction. Anyway, here are the jet streams of the Western world. Here are the surface winds of the Western world. Surface winds of the Central world depicted here. Strong onshore wind there at southern Norway, between Norway and Denmark. Strong winds there in the North Sea, right there. And these are the jet streams of this portion of the planet. Let's blast through our forecasts. But first, some near real-time data from the NASA GOES Interactive Weather Satellite Suite depicting clouds and fog over the Americas as we slowly zoom in on the lower 48. The lower 48 states of AUSA, the allegedly United States of America, former nation, now banana republic, where there is zero accountability, free speech, etc. That stuff has all been abolished since 2020. Bureaucrats doing a fine job, so make sure you do your part and pick up some merch and make Earth not suck again. Remember, the best way to get out of a hole is to stop digging. Here's your data from weather.gov. And we've got some winter storm warnings there on Mauna Loa and Mauna Kea. How about that? So some snow expected there in Hawaii and Alaska. We scrolled down to show you the key. If your location's lit, click your location on the map. It is weather.gov. So let's do some forecasts. Here's your temperature anomaly forecast in degrees Celsius based on the GFS model for the next 72 hours. as we're getting anomalously warm temperatures in the Northeast, and we'll take it, as I usually still have a sore butt when it comes to February as far as cycling goes, because most of us take a few months off, or a month off, or something like that, 6 weeks. And I'm like, my legs are going to be epic this year because of the warm February temperatures. So we're delighted about that. Again, that's your temperature anomaly forecast. You know, to quote Sarah Silverman, the great thing about global warming, folks, is if the globe's warming, that means that my sweater budget is going to be significantly lower. So I would tend to agree with that. Yeah, I want a lower sweater budget. I spend a lot of time riding in very, very cold temperatures, and I don't need that. Here's your 72-hour GFS pressure and precipitation forecast. Again, it's a dreary day over Lehigh Valley, Pennsylvania. A great day to not be going outside, not even looking out the window, for that matter. So there's pressure and precipitation. We'll also show total accumulated precipitation, since there's a lot of rain. So there's your 72-hour GFS total accumulated precipitation forecast in inches. And here's your GFS total accumulated snow depth change forecast. That's your positive snow depth change, also in inches. The GFS model, the next 72 hours, will also show the European model for new snow. Using the convenient windy.com app, there is your European model for the next 3 days. Some snow coming to Mexico, according to the Euro model. GFS model, only a tiny dusting there. So some disparities between the Euro and the GFS model occurring. Again, there's the Euro model for the next 3 days of new snow. And there is the GFS model. Significant differences there for the next 3 days on those two models. Always interesting. And let's continue on to close this mother out. So there's your NASA Goes Lightning Mapper, and we saw some Pennsylvania lightning, perhaps some thunder snow even happening in New York there. Also some lightning in Louisiana, Mississippi, and Alabama. Let's check our real-time lightning map. And indeed, it looks like there's some lightning happening in New Hampshire. There's the White Mountain National Forest. I've been there. I've been to the White Mountains of New Hampshire. And let us know in the comments if you've ever been up Mount Washington. What a crazy place that is. Check this out. One of my teammates is going to be riding up Mount Washington on a hand cycle this year. So I'm going to try to get up there and see that, maybe help him out a little bit. Mount Washington, it's largely illegal to ride up on a bicycle unless you do the Mount Washington Auto Road Hill Climb, one of the most difficult hill climb events in the world. Anyway, some active lightning cells there around White Mountain National Forest. So that's what's going on in terms of lightning. Those are the teeth of the storms from lightningmaps.org. Next time you hear thunder, check it out. Some African lightning there coming through as we stream the video live. Don't forget to visit the links below the video. Support the channel with clicks. SmashOmash.com is the official homepage for the Smash News Network Least Busted Name and News. We are still on Patreon if you find it more convenient to support us that way. Of course, again, the gold and silver Smash Team memberships are the best way to do it. You'll get the most content that way. And, of course, the best value is the gold annual paid-up subscription, SmashOmash.com. Visit the homepage. Help us out with clicks. If you didn't watch yesterday's video, watch the first about hour of it. We were actually doing a regular old everyday live stream there with the alarmist title, YouTube exclusive chemical castration. The video was demonetized before it even started to stream live. So perhaps watch the first hour of that. If you didn't, we covered some things we don't normally cover on the channel. If you haven't seen this stream, have you realized the level of interference in social media? Maybe check that one out. It talks about some of the putrid, disgusting, and foul censorship from Twitter, because we've got videos besides daily space weather. So make sure you check out our playlists. You'll find all kinds of stuff in there, like Do One Thing, the Diamond Anvil Too Hard to Smash, gaming videos, and the 12 Days of Smashmas. We'll close out today's video with some Doppler radar and some significant rain here all across the full 50 states of ALSA. There's a quick zoom in on Alaska as we've got viewers. from AUSA's largest state. Heavy precipitation there, especially around the Big Island of Hawaii. And we'll focus on the lower 48 for the remainder of the video. There is clouds and fog. And there is the water vapor map. So we've got a great impulse here. So this is going to help push this system a little bit to the east. This dry mass of air is effectively a high pressure system. We are getting some sandwiching here. This is an effective low down here. This is an effective low up here. Keep in mind this air is much more massive because it's so much colder. But yeah, so this dry mass of air here is going to help to keep this system moving, as it will clear up here by late this afternoon in Lehigh Valley, Pennsylvania. We're expecting, here's your recap, the U.S. Doppler radar map. That shows vertical motion of water droplets and ice crystals in the air column. Here is shortwave radiation, satellite-based systems showing clouds and fog when it's too dark over half the country to use a visible satellite. And there is the water vapor map. That's where we'll close things out. We hope you're getting better at forecasting your own weather. You should be able to do it. You've got plenty of ability to do so. There are plenty of instruments. If you'd ever like us to do a forecast for your area because of your weekend plans or something like that, drop us a line. Perhaps we'll consider it. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.